postgraduate students and researchers in the design, implementation, analysis, and interpretation of the data. The goal is to enable the production of top-notch research. In Prof. Kitt's presentation today, the role of statistics in research, he will explain the role of statistics in research from the planning stages of the project through the data capturing phase to statistical analysis and interpretation of the results. Thank you very much, Professor Kitt, and we are looking forward to this session.
Okay. Still good morning. Good morning, ladies and gentlemen. Can you all hear me at the back quite well? Okay, so I've already been introduced, but just from my side, my name is Martin Kitt from the Center for Statistical Consultation. I see quite a few familiar faces here, so hopefully I'm not going to bore those people too much with what I'm going to say. This presentation is going to be completely non-technical, so those of you that are scared that I'm going to sort of bombard you with lots of difficult equations, don't worry about that. The aim of this really is just to, in a sense, introduce statistics and the role of statistics that it plays in a research project to you, and hopefully highlight some key points that you must keep in mind when you are planning and executing your project. So I'm not going to give any details, I'm going to give more a broad discussion as to where we as statisticians fit into this whole process of doing research. Okay, that's just a brief outline of the talk. I'm going to just talk about the planning process and the planning of projects. I'm going to talk about the execution and when you are actually doing your projects, what you must think about in terms of the statistics. And I'm going to spend some time on data capturing because that is probably one of the sort of key steps in the statistical process. I'm going to talk about data analysis, reporting results, and then right at the end I'll just say a few words more about our center and the services that we offer for those of you that's still unfamiliar with us. Okay, so I just want to start off by talking about different types of data. And the reason why I start off with this is that it is actually quite important what kinds of data you gather, because that's going to impact what kinds of statistics will be done once the data is available. Now, in the literature, you'll probably see more different sort of classes of data, but I would like to just divide it up into three main classes, of which the first one is what we call nominal or classification data. Now, the key features of this kind of data is that there's no order in the data, so it's not like a continuous measurement that you are doing. It divides your data up into different groups. So gender is quite a good example of what we call classification data. We also talk about the categorical variable. We've got outcomes like male or female, and that will then divide the data up into two different subgroups. And as you can see in a variable like that, there's no order in the outcomes. If you are recording, say, different colors of something, then that is another example of a categorical variable where you can say blue, red, and green. Again, there's no order in that. And one need to then, from a statistical point of view, deal with that in a specific way. Okay, then the second type is what is called ordinal data. So the name sort of indicates that the order now becomes important, but it's still like discrete outcomes that you will have. So if you say have on a questionnaire a Likert type question where they can say answer on a scale from completely disagree to completely agree, then that is an example of an ordinal variable. So it has, say, let's say it's a 5-point Likert scale, then there are 5 distinct outcomes, but those outcomes do have a specific order. So the completely disagree is on the left-hand side, and the completely agree is on the right-hand side. And then the last type is now continuous data. So that is where you are doing continuous measurement. So if you take the length, or you're measuring the length of something, then that length can be an outcome in a specific range, but it can be any value depending on the accuracy of your measurement instrument. So it is different from the ordinal data in that it is not discrete outcomes. It is actually a measurement on a continuous scale. Now the categorical data are usually handled completely differently from the continuous data, and then the ordinal data is sort of somewhere in between. So sometimes one can treat ordinal data as if it was continuous measurements, or in other cases one can treat it as if it is a categorical variable. So that is essentially going to depend on the circumstance of the analysis that is going to be done. Okay, so I think that is not too difficult. It's fairly clear. So if we start looking at the planning of the project, then the aims and objectives of your project will determine the statistical content. So it's obviously extremely important to have a clear idea of what the aim and objectives are, and then from those objectives one will then determine, well, firstly, do you need any statistics? There are obviously many projects that are done where there is no statistical component to it. But then if there are statistics that, or let's say data that need to be gathered, quantitative data, then most probably that data will have to be statistically analyzed. So the kind of data that you're going to get is directly derived from the objectives of the project. Okay, so already at this stage, proper statistical planning is essential, and the statistician should preferably already be involved at this stage. We would prefer to, in the planning stages, already sort of have our inputs there, because I am involved in many projects where people just come with the data to me, and then in many cases when I look at the way that they've conducted the experiment, then I can see that there are probably better ways of doing it. So it is actually quite important that we get involved in the planning stages already. Okay, so there are various issues that one needs to consider when you are now still in the planning phase and you want to, say, gather some data. Then usually you must define your population. So if you are going to do a study on the students, then you can say, okay, my population is just, say, Stellenbosch students, or it can be a wider study where you can say the population is students across the whole of South Africa, or if you are very ambitious, across the whole of the world. But that is going to impact on how you are going to gather your data and how you are going to select cases to become part of the data. So defining the population is quite important, and again, that is already has to come in at the planning stages, because the deductions that you can make from your statistics obviously only apply to the population that you're working under. So one needs to have a clear idea of what that population is, that you maybe not make conclusions on a wider population, although your study was only focused on a smaller population. Okay, then in terms of conducting experiments now, or gathering your data, that is again where we as statisticians play an important role, is to give advice on what is the best experimental design to use. If you are doing some kind of intervention, then you might want to have, say, 2 different groups, where there's an experimental or control group, or you might say, okay, we can do pre and post testing. between the interventions, and these are discussions that we can actually give quite, I think, a useful input as to what will be the best option in terms of the experimental design that you can use that will essentially optimally answer your research questions that you have. Okay, I'm going to spend a bit of time on questionnaire design for those that will perhaps at some stage do a survey with questionnaires. And the reason why I specifically highlight this part is that I deal with this quite a lot, and I can see that people sometimes really struggle with questionnaire surveys, and essentially because of poor planning and because of let's say not a proper design of your questionnaire. So I'm going to give some pointers on designing questionnaires, but then again it is probably a good idea once you have the content of your questionnaire all ready and set up, just to speak to a statistician and say, this is what we want to do, this is the kind of responses that we are thinking about. Are there any suggestions that you have on that? Okay, so usually what is the best way to approach a questionnaire design is to see whether there aren't any existing questionnaires that will actually enable you to collect the data that you want to collect. Because in many cases other people have already done similar studies to what you are doing, and then it's actually a good idea to sort of build on what they've done and take their questionnaires if they give you the permission to do that, which in many cases they do, and then adapt your questionnaire based on that, because it is in many cases quite difficult to sort of start designing a questionnaire completely from scratch. So hopefully other people have already done a lot of thinking for you, so you can just basically build on that. Okay, so based on previous studies, what's very important is to, in this planning stage and the design of your questionnaires, to already start thinking about what kinds of validity is appropriate for this questionnaire, because I always get this thing after they've already conducted their research. Then they come to me and say, okay, but what reliability or what validity must I now do? And it is a good idea to start thinking about that at this stage already. There are various different kinds of validities. Sometimes these things are applicable, sometimes they are not, and especially for those that are sort of writing theses that have to be examined by an examiner. Let's say reliability analysis is not applicable to your questionnaire, then you must state that in your methods so that when an examiner reads that he will notice that you have already thought about that, and that will be the reason why it is not included, because many times we get comments back from examiners saying, why haven't you done reliability analysis? And then, only then do the people start worrying about that. You must actually start worrying about that when you are actually designing your questionnaire. Okay, responses to questions. You can have like a list of choices where there can only be one choice selected. There again, you must sort of carefully think as to what is the full scope of possible responses. You can have multiple selections, which is also a list of options, but the person can select more than one option. And you must be very clear on your questionnaire to make a distinction between the two. So cases where you can only make one selection versus other cases where you can make more than one selection. Then if you want to collect continuous data, something like age is a good example. People tend to think that they always on a questionnaire have to have these choices and say age bands from 20 to 30, from 30 to 40, 40 to 50. But it's not necessary. If the respondent can give you an exact number, let them write that exact number in, because that is obviously the most accurate data that you can have. So for something like age, I will always advise people to just put a block in where they can actually write in their actual age. Things like income and so, which can be sensitive data, or people might struggle to give accurate answers. In those cases, one can start using like ranges of sort of options with different ranges in there. But ideally, one would like them to give the more accurate answer, because that again will give you more accurate statistics afterwards. Okay, you can obviously have open-ended questions where you ask a question and they can write things in their own words. My advice here would be, if you can at all have a list of choices, rather put the list of choices in, because I've seen some very strange answers when people are sort of free to give their own responses. So if you, an example would be if you ask them what their culture group is, if you leave that open, then you will get many different answers to that, whereas you can probably give a nice list where they can select from. So open-ended questions generally are only used when you want them to express opinions on certain things, and you want them to express those opinions in their own words. Just note that to analyze that is time consuming. The open-ended questions will not be something that we as statisticians will deal with. You'll have to do that yourself. And it essentially entails reading through all the scripts that people have written and summarizing that. So it can be time consuming, but it can also be quite information rich. So it is in most cases a good idea to have a couple of open-ended questions where you can let people express their opinions in their own words. Okay, then Likert scales are used quite often, and there it is sometimes an issue as to, do you now use a 4-point scale or a 5-point scale or a 7-point scale? From my side, I don't think it really matters all that much. If you have like statements where they can say on a scale from completely disagree to completely agree, then the one thing that one can take into account is whether it is an even numbered scale or an odd numbered scale. Because with an even numbered scale, if you have a 4-point scale, then you will say just have completely disagree, disagree, agree, and completely agree. So if a person answers that, you are forcing him either to the left side or either to the right side. Where if it's a 5-point scale, then there's always one of the options that is right in the middle, which you will maybe call neutral. And you can just think about whether somebody can be neutral or whether you want to essentially force the people to go either the one side or the other. Okay, be careful of the wording. I've sometimes seen that people think that if they start off with words from, say, completely disagree to completely agree, that must be the wording all the way through. But sometimes you will phrase a question slightly differently where they are not disagreeing or agreeing. Let's say you ask them how important is something, then you will have words like from very unimportant on the one side to very important on the other side. So sort of just be careful in terms of the wording, that the wording fits in with the context of the question. Okay, make sure it's ordinal. I get this quite often. There's an example where you've got, say, those words. Now, I think most of you will say, okay, but there's not a problem with that because it ranges from completely disagree on the one side to completely agree on the other side. But if you look at the middle option where one say unsure, now for me unsure does not really fit into that scale there, because if you are unsure, then maybe you don't have enough information to actually answer the question. Then it should, in the statistics, be treated as a missing value. So what would be, for me, more appropriate is to say have a word like neutral in there, because somebody can obviously be neutral about it. They're sort of sitting in the middle, so then they do have enough information, but they don't particularly sort of side on the one or the other. Okay, so that is just a couple of points on designing questionnaires. Again, I sort of would advise that that we look at your questionnaires once you have designed them, so that we can give some inputs according to the statistical aspects. Then the next point that is quite important, and this is also something that obviously needs to be addressed in the planning phase, and that is the question of sample size. Now, the first point I want to make about that is that in many cases that is not an easy thing to deal with. So just keep in mind that you should not, the day before you want to start your project, come to me and say, okay, how large must my sample be? Because I'm most probably going to ask you some questions that you won't be able to answer immediately. So just keep that in mind, that sample size questions, if you ask me just how large must my sample be, then I won't be able to answer that question, because there are many factors that play a role. The main issue is that in 99% of the cases, your sample size is sort of governed by time and money. Essentially, your practical constraints that you have. So if you come to me on a sample size issue, the first question that I will ask you is, how are you going to collect your data? How much time do you have to collect your data? How much resources do you have? And then almost in 99% of the cases, that will sort of fix your sample size. So if you say to me, I've got 2 months to collect my data, it takes me 1 day to collect, say, one set of data, then obviously that will then determine your sample size. Or in the medical field, they have to say, wait for patients to come in to form part of the sample. Then you have to sort of get an idea of how frequently do these patients arrive, say, at the hospital, and again that will then determine what your sample size will be. So in most cases, one can already beforehand, based on the practical constraints, say what the sample size should be. Sometimes it is required to do some sample size calculations. Now this is where the difficult part comes in, is if you want me to do a sample size calculation, you want me to estimate what your sample size should be, and this is not an easy thing to do. And the reason why it's not so easy is because it requires information that is hard to come by and sometimes doesn't even exist. So that is where the big problem comes in. Because in most cases, if you ask me what the sample size is, I'm going to ask you questions about the data that you are still going to collect. So I'm sort of asking you about things that you haven't done yet. And that is where the big problem with the sample size calculation comes in, and where most sample size calculations are done on such thumbs-up figures that they don't really, for me in any case, mean all that much. But sometimes people are very adamant that one need to do these sample size calculations, and in many cases it is also quite relevant to do that. Okay, so the things that you need to take into account when you are doing sample size calculations are what we call effect sizes, the variation in the data, and the power of the sample. Now, I'm not going to explain what all these concepts mean. It is just giving you an indication of the kind of information that I'm going to require if you start asking me about sample sizes, and it gives you an idea that it is not so easy to collect this data. So usually those kind of things that I ask you is not known at the start of the project before you start your data collection. Then what people most of the time do is they go and look in the literature and they see, have other people, have they done similar experiments to you? And what then happens is they have then reported certain results with certain statistical figures in there, and then one can perhaps use those results and base your sample size calculation on what they have done. So that is quite a popular way of going about it. So again, if you come to me today and you say, you want to start tomorrow, then you must keep in mind that I'm probably going to ask you to go and look for some literature on people that have done similar things to see whether they have reported statistics that one can use. The other way that is slightly more difficult is to actually do a pilot study. So one can build into your project like a pilot phase where you say, okay, I'm going to just use a sample size of say 20, and in that case the actual sample size is not that important. And then do all your measurements on that pilot sample, and then based on those measurements one can then get the necessary statistics to do then a proper sample size calculation for your main study. So that is also very popular and probably one of the best ways of going about determining sample sizes. But that obviously takes a bit more effort now from your side. So hopefully this will give you just an idea that the sample size issue can be, in many times, be quite a tricky thing to talk about. Okay, so now, once you've now completed your planning and you start doing your experiments, there are certain things that you just need to keep in mind. This thing is now. Okay, so pilot studies that I've now said can be used for sample size calculations, can also be used for other reasons, and that is primarily to get all your procedures in order. So in most cases I will advise that you do, even if it's just a small pilot study, let's say you've got a questionnaire that you want to do a survey with, then it's always a good idea to get, say, just 5 or 10 people to complete the questionnaire and get feedback from them as to what questions are difficult to understand, and just to sort of get an idea of what are the practical problems that you might experience once you start doing your main study, because you don't really want to experience those practical problems once you are into your study and you cannot turn back or change anything anymore. So pilot study is an essential thing in most cases. Okay, sort out your procedures for data capturing, and again here we as statisticians can and should give some advice. I'm going to talk about data capturing just now, and I'll there explain in more detail as to why I say that we should be involved in that. But this is sort of at the start of your execution. You will start thinking about how am I going to collect my data, because you must remember we are always doing the statistics from statistical packages, so data always need to be electronically captured in some way. Okay, one can also think about it, sort of ties in with the pilot study, but sometimes one can let the study run, say, for 6 months and then take all the responses that you have at that stage and do an analysis on that, get some interim results on that, and then decide from that, do we need to go further, and if also at that stage one can maybe recalculate sample sizes. So if you are in a position to do that, sometimes that can be quite a good idea to sort of have a like a point halfway through or so where you will do analysis on the current data that you have so that you can get an idea of what's happening, and based on that either replan or say, okay, no, things still look fine, but I do need more data, so I'm going to carry on as I have been up till that point. Okay, now for data capturing, my sort of plea here is please make sure that the data capturing is done correctly. There are some strict guidelines, unfortunately, from our side that one needs to adhere to, and I'm going to give more detail about that, but essentially, especially if you're using something like Microsoft Excel to capture your data, then it has to be in a specific format. I'm going to show you some examples just now. But the reason why I'm so adamant about that is because of what I'm saying there. It takes literally for me 90% of my time to clean up data and 10% of the time to do statistical analysis. So most of the time that I spend in my office is cleaning up data. So even if your data is correctly captured, then there's still a lot of cleaning that need to be done. But if the data comes back in a bit of a mess, then it really takes me a long time to get that in the right format. And in many cases, I'm going to send you back with the data, so it's going to be then extra time for you. So it is advisable to, right at the start, when you start collecting your data, to make sure that you have a clear structure that you use for collecting the data, for capturing the data. Okay, so most commonly it is done in Excel. That is usually what I advise people to do. If you are to some degree versatile in a statistics package, you can also do your data capturing there. The advantage there is that the statistics package will to some degree force you to actually capture it in the right way, but Excel is just a much more user-friendly tool to use, and that's why I always prefer to do the data capturing in Excel, because you can use nice formulas in there if you have to make some calculations or whatever. But the problem with Excel is that you start with a sort of open, clean spreadsheet, and people have very ingenious ways of actually organizing their data on a spreadsheet like that. And sometimes visually it looks very nice, and I'll show you some examples now. But unfortunately, to get that data into the statistics package, we need it in a specific format before we can do that. Okay, so some guidelines as to what you must do. So different variables that you are measuring goes in columns, and different subjects or items that you are measuring goes in rows. So if you have a sample of size 20, then in your data you will have 20 rows, where each row will contain all the data for a specific subject or sampling unit that you are measuring. Okay, each variable must have a unique name. In most statistics packages that is required. In the package that I use, it is not a requirement for the variables to have unique names, but obviously you're going to get very confused if you start naming certain columns by the same name. And if we start doing the statistics, then eventually you're not going to know which column the results are referring to. Okay, what's quite important in the Excel file, the names must be in the first row. So your data must start in the second row, because that is how the data gets imported into the statistics package. And that is where people mostly make the mistake, is that they use sort of like the first 3 or 4 rows for identifying their columns. Now again, from a visual point of view, that is fine, but essentially we'll have to redo that before we can import the data into the statistics package. Okay, if you have different groups, let's say you've got a control and experimental group that need to be compared, the data must be captured on the same sheet. I often get that where they give me either 2 sheets or 2 different files where they say, okay, right, this is the data for the control group, and here's another file with the data for the experimental group, or you've got a pre and a post test. Then they say, here's the data for the pre-test, here's the data for the post-test, then eventually I have to merge the data sets to do the analysis. So right from the start, essentially try and capture the data all onto one sheet. It sometimes makes sense to have them separately, especially if you're collecting quite a lot of variables, and it becomes practically a bit difficult to have many columns in your Excel sheet. Then one can think about using more sheets. But remember, Excel, they've got a lot of columns. It sort of almost got an infinite number of columns, so you can use as many columns as you want to capture your data. Okay, give descriptive names for the variables. I think the days of having just 8 characters available for a variable name, those days are gone. One can give nice descriptive names, but again, don't use long sentences as well. So try and use a short and descriptive name as possible. Okay, also if you've got nominal variables or categorical variables, like something like gender, people tend to think that they have to put in codes in there, so they always say, but let's code a male as a 1 and a female as a 2, and then put the numbers 1 and 2 in the data. That is not a requirement. You can actually put the actual text in there. In fact, I as the statistician prefer that you do that, because sometimes I'm not quite sure what the numbers mean, and I think it's maybe a scale that you've measured where the numbers actually refer to different categories, and then I might do the statistics completely incorrectly. So you can put the text in there, we can deal with that. Okay, for ordinal variables, one can think about using numbers. So if you've, say, got a scale that goes from bad, medium to good, you can, in some instances there, put in the numbers, because obviously that is an ordinal variable, so the numbers actually do have an order, and it means something. So, okay, let me show you some examples. To make this slightly smaller. Okay, so there's now an example of a data set that was correctly set up. So you can see that the names are all in the first row. You can see the nice descriptive names that are provided there, and then all the data for one person in this case is given in a row, and you can see that the sample size is 25. So there are got the first row for the variable names, and then the 25 people after that. Okay, so if one look at that one now, so you can now see that is now a very nice example of where people used 3 rows to define their columns. And unfortunately we cannot use it that way. So probably if you bring me a data set like this, I'm going to say to you no, but you'll have to rename these columns and just put the names in the first row, because if I import this data into the statistics package, it's going to take rows 2 and 3 as already part of the data, and then the data will not be correctly imported. Okay, there's another example of data that sort of looks quite nice, but it is not correctly organized. So in this case, I'm again going to say we'll have to reorganize this, because I cannot just import the data as it is into the statistics package there. So I think it is, especially if you've got fairly complicated data that you're capturing, it is always a good idea to come and speak to us before you start capturing, and that we maybe set up a system for you for capturing the data, so that one can have the least troubles once we start cleaning up the data, that we don't have to copy and paste and so on. Because if you want to sort of reorganize this, this is where the errors come in, where you sort of copy and paste incorrectly, and then all the statistics will also not be correct. Okay, I do have a system in Excel, especially for questionnaire data, where I can actually customize an Excel spreadsheet based on your specific questionnaire. And that is, for me, the preferred way of capturing the data, because it makes the data capturing for you much easier. And also, then I know that the data will be in the correct format with the least amount of cleaning up for me to do if you use that. So it is a system that works fairly easily. If it's a fairly simple questionnaire, then I can just sort of set up the template to create the sheet for that myself. That is, it goes very quickly. For more complicated questionnaires, I might show you how to set up the template, then you can actually set up the template yourself. And once the template is set up, then it is just a press of a button to create the actual data sheet where the data will be entered. Okay, just keep in mind we haven't really had sort of any questions about this, but we don't do data capturing at all, so that is your responsibility to do the data capturing. We do have people that we can refer you to if you don't have the time to do it yourself. But this is probably the most important step because one can very easily get lost, and as I say, if you have mistakes, then analysis need to be redone, and I cannot stress how many times I have to redo statistics based on incorrect data entry. So, you know, in many cases one cannot pick up all typing errors and so on, so there will always be from time to time errors in the data, but be careful with the data capturing that you capture it as accurately as possible. Because in many cases one do pick up the errors that there are, but in other cases where the errors are sort of fairly subtle, you might not pick up that there are actually, say, typing errors in there. So this is an extremely important part of your project, this data capturing, because obviously it's a question of garbage in, garbage out, so you want your data capturing to be as accurate as possible. Okay, so now once the data has been analyzed, we get to the data analysis part. This is most of the time handled by the statisticians, so we do statistics for many people, but that is essentially your decision. There are many cases as well where people want to do their own statistics. I always start off by doing summary statistics like frequency tables, mean, standard deviations, etc. And this is for me always an important first step, just to get to know the data and also to hopefully detect some problems with the data, and maybe if there are typing errors, then one will pick it up in here. There's an example of a histogram. I always draw histograms of the data. So you can see there was this one case that was an 11. So I'll probably, when I see this, I'll go back to you and say, is there not perhaps a problem here? And you'll say to me, yes, there is. This is a scale from 1 to 5, so that 11 is obviously a typing error, so it should probably just be a 1 or something like that. So in that way, one can already detect many problems or errors that are in the data and correct them before you start doing the analysis. Okay, yes, just more examples of visually displaying your data. I'm not going to go into any details with that, but one can learn quite a lot in this sort of first part of the statistical analysis before you even started doing any sort of, let's say, proper or serious statistics. Okay, then once, now that is a step. If you just send me the data, then I can do that without any input from your side, is to do the summary statistics. So that I can do, but after that, you need to give me guidance as to what need to be done. So the statistician must be guided by the researchers. I get it too much where people say to me, okay, but you decide what statistics need to be done. That's not a decision I can make. You have to do that yourself, and you have to understand what relationships you want tested and put that through to me. Okay, so you can formulate, say, like a list of questions that you want answered from your data based on the aims and objectives of your study. Then from these list of questions, the statistical hypotheses will be derived, and that again is where we play an important role as to sort of identify what is the proper statistical hypothesis to be tested to answer that question of yours in the best way. And also remember that we as statisticians are not experts in your field, so please, in the way that you describe to me what I must do, try and keep the descriptions quite simple. If you use your own jargon, I'm not going to understand what you are asking. In many cases, well, in all cases, the data will have specific names for the different variables. So if you give me instructions, use those names as they appear in the data. Then I will know where to look for them, and I will then probably understand what you are asking me. Okay, then there are specific techniques that one can use to answer specific questions, and what I want to stress here is that you should not really come to me and say, I want you to do a regression analysis, because your results are not driven by the statistical technique that you use. It's more driven by what are the questions that you're asking. So if you say to me, I want a regression analysis to be done, then I'm going to start asking you now, what kind of questions are you asking about the data? And then if that questions that you're asking about the data, if that indicates that the regression will be done, then I will do a regression. If it indicates other statistical techniques to be used, then I will do those other statistical techniques. And I've actually had people that have been very cross with me because I did not want to do a regression for them because it was not applicable for what they wanted to do. So just keep that in mind, because especially as students, you get instructions from your study leaders. So the study leaders say you have to do a regression analysis, and then the statistician is unwilling to do that, and you're now sitting in the middle of the two. Okay, appropriate techniques are dependent on the hypothesis and the types of data that I explained to you right at the start. Here are some examples, not comprehensive. So, for instance, if you are comparing means between two groups, an analysis of variance will probably be the most appropriate analysis to do. If you are comparing, say, just categorical variables that you cannot calculate the mean for, you will use things like cross-tabulation and the chi-square test. So these are just an indication of that once you have got a certain question that needs to be answered, one needs to derive the statistical hypothesis and then the appropriate statistical method from that. And the statistician there plays a very important role in identifying what are the most appropriate statistical methods to use. Okay, there are obviously many more examples. This is probably the two that I encounter the most in the consultation that I do. There's just one example of comparing two means. This is just to give you a feeling for the kind of output that we will provide if we do the statistics. I'm not going to go into too much detail there. Statistics packages that we use, we in our center have sort of standardized on Statistica for various reasons, which I'm not going to go into detail now. Statistica might not be appropriate for you to use. It doesn't really matter, but for us it is the best package in terms of the volumes that we encounter. Then there are other packages like SPSS and SAS. Now for those first three, the university have got site licenses for all three of them, so you can use any of them. Then R is another statistics package that is becoming more and more popular. It's probably not that easy to use, but it is open source software, so that is completely free for you to use. You can download it from the internet and start using it. And then obviously there are various specialized packages that we use for specific, more complicated statistical analysis. So we have got a whole suite of those kind of packages that we use for, let's say, structural equations modeling, which is not really found in your standard statistics packages. We've got the software to do that. Okay, so when you are reporting your results, that is the responsibility of the researcher. Okay, so you are responsible for writing up and reporting the results. I've had some cases where people ask me to write the results for them. Then I say, no, that is where my responsibility ends. It's your responsibility to interpret the data and also then report the results based on the interpretation. We can obviously, and we will, it is an important step of the consultation process that I follow to assist you with the interpretation. So we will have like a full session where I will explain to you how the results are to be interpreted, but then you have to go and do the writing yourself. But we can also then look at the result sections that you've written and read through that and give comments and suggestions based on what you have written. Then there's always this issue of co-authorship if you are publishing. Now from our point of view, the question is, now should the statistician be a co-author on a paper? And what we say is that is the decision of the principal researcher. If you feel that I have done enough statistics or given enough of an input and you want to put me on as a co-author, then in most cases I'll be happy to do so. I think there was only one case so far where I've actually declined an authorship for specific reasons again. But it is primarily the decision of the researcher, and please don't try and say to me, but what guidelines must you use? It's up to you. And what I see is that there are certain sort of fields of studies where people have different points of views on that. Specifically the medical field, they tend to put almost everybody that had anything to do with the study on as co-authorships, where in other fields people tend to be not really inclined to put the statistician on as a co-author, but that's going to be your decision. If we are co-authors, then we want obviously insight into the article, then I want to read the article before it is submitted. Okay, just a couple of points on our center itself. Our primary aim is to assist students and researchers, so I am part of the non-academic personnel of the university, so I don't do any formal lecturing, so these presentations are the closest I get to lecturing. So my full-time job is to do statistical consultation. We are 2 people at the moment. It's myself and Professor Darnell. He was the, I see there I've still got him as director. He was the previous director of the center. He's now retired, but he's still assisting me on a part-time basis. So you can contact any of the 2 of us for an appointment. Just note that I am at the USB campus on a Tuesday, so I've got an office there, so I sit there for the whole day. So that is primarily for MBA students, but then there are also people from the health sciences faculty that come and see me. Or basically anybody that's living on that side of town and you don't want to drive through to Stellenbosch, you can make an appointment with me at the USB campus. Okay, in terms of funding, our center is centrally funded by the university. 50% of our budget, so the other half we have to unfortunately get in via consultation fees. But because we get the central funding, we can keep the consultation fees fairly low. So for 2017 it is 280 Rand an hour. But the main thing that you must note here is that is not to be paid by yourself. It is to be paid by either the department or by your study leader. So we are unfortunately not geared to invoice students personally, and we are also of the point of view that your department should assist you in the funding of the assistance that we provide. So if you want to come and use us, just speak to your study leader and see what the options are in terms of the consultation fee that need to be paid. There are 2 faculties that actually do make funds available, EMS and education. So for those students, essentially our service is free because the dean has a fund that cover that 280 Rand an hour that we have to charge. Okay, so just keep in mind that we do not invoice students personally. Okay, and that is what I want to say. I don't know if there are any questions. You are welcome to ask me questions now.
Thank you so much, Professor Keith,
Okay.
for sharing your knowledge and your expertise with us. We really appreciate your time.
It's a
And we
pleasure.
have a small gift as a token of our gratitude to you. Thank you so
Okay.
much.